Hello, everyone. We just opened up the room. Let's give it a minute for Zoom to let everybody in. Thanks for joining us. Good evening and maybe good afternoon if you're joining us on the West Coast. And welcome to tonight's webinar, Step Ahead with Desmos Classroom Lessons. My name is Heath. I'm on the math team at Amplify, and I'm joined tonight by my colleague at Desmos Classroom, the one and only Mr. Dan Meyer. Hey, Dan. Tonight, Dan is going to be your teacher tonight as he walks through an Algebra 1 lesson in Desmos Classroom Lessons called Finding Desmo. Then I'll talk a bit about how Desmos Classroom Lessons help students express their brilliance in your classroom every day. Before I pass it over to Dan to get us started, just a couple of quick housekeeping notes from me. You will be in listen-only mode for the duration of this webinar, but we do want to hear from you. Use the Q&A box to ask questions. We'll answer what we can as we go. And then we'll also leave time at the end for some Q&A time as well. We do have some colleagues monitoring the chat for us tonight. So you can also ask questions there and our team will answer those as we go. Tomorrow, you will receive an email with a link to the recording of tonight's session to revisit or maybe share with a colleague, as well as a link to a survey about tonight's webinar. We'd love your feedback so we can keep improving these webinars for the future. That does it for logistics, so I will be quiet and disappear for now and hand it over to Dan to lead us through the lesson.
Be gone, Heath, and thank you for kicking us off. Really appreciate it. And good evening, good afternoon, good morning. I'm going to assume that there are people here from all over the world here to do math with me today. What a treat to be here with you. My name is Dan. I was formerly a high school math teacher in public schools here in California, and I was one of the original authors of the first Desmos activity, which is now blossomed and flourished with a huge team behind it and turned into this full curriculum, grades 6 through 8 in Algebra 1. I'm thrilled to teach with you a lesson I've never taught with anyone before, so I anticipate learning some of its ins and outs along with you in real time. That'll be a treat for me, hopefully for you as well. Along the way, I'll pepper in some thoughts about what it takes to teach math well and math with technology well, especially. This lesson today, it's going to be in one of the I think the hardest areas to teach well, which is statistics. And the reason I say that is that statistics is an area where, yes, we have Honduras in the house, bienvenidos. Statistics is an area where the operations are so easy. Like it's so easy to calculate the mean, or the standard deviation even is just like a matter of computing some steps with numbers. It's trivial compared to how hard it is to understand what those operations are doing conceptually. There's other areas of math where the operations are really tricky, like the quadratic formula is a tricky set of operations that describe a conceptually complex area of mathematics. They kind of have parity, they match each other. But stats is an area where I could go into a stats class and help everyone get the correct answer, and even though they did not understand what they were doing at all. That's what stats offers us here. And so what we've done at Desmos with this lesson coming up here on standard deviation is created experiences that don't just help students with the operations, but help them understand conceptually what's going on. We got folks saying hello in the chat. I just want to see where we're from here. Let me know where you're calling in from. And if you want to toss in what you teach, or if you support teachers, or if you're a principal, or if you're a student who somehow wandered into a room full of math teachers and you're desperately trying to get out right now, let us know that as well. We got middle school math teachers. We got high school math. We got Jamie Winslow supporting teachers. This is great. This helps me get to know who my friends are. And I consider every participant in every webinar I've ever given my friend, hope it's not too weird to say, my best friend. Okay, we got Sacramento, California. Love to see it. Mom's on the line. Hey, Mom, I swear I'll return your call. Just kidding, my mom's not here. It'd be so weird. It'd be very awkward, but could happen. Okay, this is great. This is great. Here's one thing I want to say though, folks. I need to say this, is that all of your roles over here in the chat flying by, middle school math, high school math, coach, administrator, I need you to forget those for now. I need you to forget about those. And instead, I need you to be an Algebra 1 student, perhaps a student in 9th grade, maybe 10th grade, who knows, or someone accelerated in 8th grade. You can choose the level of challenge you want to offer me here. I will find you more challenging the more you act like students, which is to say you have a desire to feel brilliant and smart. You have very incomplete knowledge. You have knowledge you are trying to finish and master. In mathematics, though, you're not going to speak to me like a math teacher, I hope. I want you to see what it's like, how this curriculum makes room for students at every level and helps you, the teacher, develop that understanding. Enough setup here. Here is my screen. Okay, here's the situation here, folks, is that what I'm going to ask you to do, the first thing I'll ask you to do is to look at two data sets and tell us how they're similar, how they're different. This is the kind of a warm up that we start with a lot in Desmos lessons, which is one where students can get super numerical and quantitative if they so choose, but they can even more than that. We make room for students just to speak very concretely and qualitatively about that kind of work. So right now, what I'll ask you to do is I'm going to put in the chat, and I'll invite my colleague Megan to put in the chat as well, a link that will drop you in. And I'm just going to ask you to, what's up, buddy? How's your rest time? Going really good? Yeah. Are you resting like you're supposed to? I'm going to go ahead and paste you right here to that first screen. All right. And then in the chat, I'm also dropping that join. You didn't go poo poo. Okay, cool, man. I'll see you in a little bit. Yeah, go for it. Right on. Join us in this activity. Well, that could not have gone worse or more embarrassing. We could have. Okay. Right on, folks. Let's see. I got 7 people in. And my role here, what I'm wanting to do is to just look at very interesting ways you folks think about the mathematics here. Yes, you'll get a link to the recording, which will include. Awesome. Okay. Let's see how we're rocking here. People rolling in, 95 people in the activity. Join us, join us, join us. And let me know how you're thinking about it. Corinne, there's a link that we'll post again here. Let's see here. Yeah, there we go. Click that, and then you can just say continue without logging in, type a name, whatever you want to do here. I'm going to go ahead and pause you real quick in 10 seconds. Got to see what your folks are saying here, though. Ooh, I love this. Okay. 5, 4, 3, 2, 1. All right, would you folks join me over in the Zoom window? And I'm just gonna offer a quick little scroll on through, not every response, but just like a few, like my sense of the responses here. So here's what I love is that people are talking about things like, this right here. I love this, the same number of items on both, and one is all together and the other is not all together. And I love this. This describes very concretely and in a sensory way, a visual sensory way, what the person's seen. And I love that we make room for that. If our warm-up was calculate the mean, or describe the measure of central tendency of these two sets, you've got a screen one, a first question that just locks a lot of kids out. So I love that right there. I see those. I also see people saying here's where the dots are. I see people talking about the mode, though. There is the mode is 5 on both. And I just want to calibrate here a little bit with you folks. You can feel free to be less of an advanced student than this. I'm very interested in helping students, especially those who have historically felt excluded from math class. This is reflecting more of a math teacher mentality, perhaps. I invite you to be more of a math student mentality. Okay, so right now, what you've just seen is a quick preview of the Desmos Teacher Dashboard, which is one of the most powerful tools I have ever used for supporting student learning about mathematics and about themselves as math students. This right here, you've seen me, first of all, here's the summary view, which shows me everyone who's logged in, tons of people. I'm gonna go ahead and press a button called Anonymize here, which lets me changes all of you folks to the names of mathematicians from throughout time, space, history, and your students will sometimes start looking up these different mathematicians and what their contributions were. We've sampled them, especially with an eye towards including people, overrepresenting people who have been underrepresented in math communities historically. So here you are. I have you paste to screen 1. I have you paused. You can't work on this right now. And what I'm gonna do right now is tell you what the next work we have to do here. It involves a fish tank, and I'm super excited about this. Here's the deal. All you gotta do at first is just add 10 fish to your tank. It can be any 10 fish you want. I would love to know which 10 fish you're choosing and why. It says tell a partner. You don't have a partner next to you, but we love having activities that are have 2 students on 1 laptop. So the laptop, rather than being the whole show, it just facilitates the show, which actually takes place between 2 students in conversation with each other. I'm going to invite you to go ahead right now. I'm going to paste you to that screen. And none of you can do work there yet until I press unpause. So go ahead and create for yourself a fish tank with 10 fish. And I want to just like see, I want to see right here. I want to see what kind of fish tanks y'all make. What seemed good to you? Wrap up this part. We've got some seriously interesting fish tank making in a moment here. I just want to have a look at your fish tanks. Let's see here. Pausing you folks, perfect in 10 seconds. 9, get those fish tanks in. 7, 5, 3, 1, and 0. I pressed the mute button rather than the pause button. Check out, go ahead, head back over to the Zoom window here. And I'm seeing on my side here, loads of interesting fish tanks. Whoa, what's going on here? What's going on here? Carl Gauss, AKA Joellen. Joellen, you've got a lonely fish here. This is a jumbo yellowfish. It needs to have friends. So me, the fish tank I wanted to make here, I'll just share with you what it is 9 of these, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then just this one right here, which I kind of imagined was like the boss of these other 9 big ones, you know, kind of the leader of the pack. That's the fish tank I wanted to make. Here's what we're going to do is I'm going to invite you folks to think about a new term right here. Well, first, you're going to see, what you'll see is a dot plot attached to the fish tank. We can describe things like fish tanks with a dot plot. So you'll make one of these right here. Someone says, I would like fish that are close to the same size. So build one you think they'd like, and just think about, we can't discuss yet, what you notice and wonder about the dot plot. What I'll do here is press this plus symbol up here on the pacing guide. And what that does is it opens up this next screen. So those of you who are still finishing your fish tank have another moment to complete it. And the rest of you can move ahead to that screen. I want to see the different kinds of fish tanks you make. I'm going to pick 4 different fish tanks. I'm going to pick 4 different fish tanks that all have fish that are close to the same size. And we'll have a look at the dot plot. Okay, you're unpaused. Go ahead and head over there and let's make a new fish tank and see what it looks like. All you for like 30 seconds. Shout out to Joe Ellen with a very, very thoughtful reason why you just included only the one biggest fish. It needed to be kept alone, needed a lot of space, had some chompers. Yeah, big fan. Ten seconds, and you got to see some of these right here. Yeah, this is so interesting. 3, 2, 1. Come on back and have a look at some of your classmates' fish tanks. So what I'm seeing, first of all, are a lot of fish tanks that have exactly one kind of fish in them. And there's this curious thing, like I see now we have dots that are all stacked up. I see this thing called standard deviation, 0 grams, all the same size fish. Something new to us called standard deviation is 0 grams. What's interesting to me is I see now like people that have included fish of 2 different sizes, but very close together. And so right here, the standard deviation is a little bit different. I notice how close this is to 0.5 grams. I'm wondering if it's possible to create a fish tank that has a standard deviation of exactly 0.5 grams. In particular, I'm wondering if we put one of these dots over in the other stack. So just to be curious here, I'm going to toss in 5 of the 4-gram fish and 5 of the 5-gram fish, and interestingly, there's 0.5 grams. We'll be thinking a lot about standard deviation in the activity. Come right here. Just want to check out a couple more and see, oh, look at this right here. Someone's got like a even wider standard deviation. So on this next screen, I'm very interested in what happens, what you think about if I press the student view here. We're going to offer you 3 different fish tanks. And what we're talking about here is a way to measure how spread out the fish are, their weights, how spread out they are, is something called standard deviation. Now, there's a lot of ways to define standard deviation. If you folks have taken some math in the past, you know what I'm talking about. There's some very formal ways to define it. There's algebraic ways. There's ways that have all kinds of symbols to them. We're not going there today. For this right here, all we're doing is trying to develop a sense of what this means. So measuring the spread of the fish, you're going to look at 3 different fish tanks, A, B, and C. And I'm going to ask you folks, what do you think the word standard deviation means? Here, it's like it's one kind of number. Here, it's a little bit smaller. Here, it's a very large standard deviation. And again, your goal is not to be mathematically perfect, but to be mathematically interesting, to reflect what's going on in your head, which is of interest to me and all of us. So give your best thought here, and then I'll join us back together and pick a few ideas out that I think are going to be really helpful for us. Okay, I'm going to go ahead and paste you over there, and you're unpaused over to you folks. Let's rock and roll. 2 minutes to come up with a definition, an explanation of what you think standard deviation means. Let's hear about it. Wow, I'm getting off track here, folks, because these are just so interesting. Okay, we've got 3 more questions where you're going to make fish tanks. I think you'll learn something more about this idea about standard deviation. But do come on back to me here and check out 4 different responses. I think these are perhaps the 4 most interesting to me. Let's see here. Okay, so Cindy asks, I can just see 3 classmates' responses. Is that intentional? And that right there, like we dislike digital experiences that make students feel more isolated and love them when they help students feel more connected to each other. And so what we try to do is expose you to 3 other student responses after you've submitted your own. I'm going to share with you 4. I can see all of them on my screen. I'm going to share with you 4 that I think are just really worth our time. Not all of them are correct. Very few of them are fully correct, but that's the nature of mathematical thinking. It's always in process, always partial, never completed. So check out the screen over here. Someone asked me about the timing of this webinar. I'll be offering a little bit more of a mathematical experience for about 10 more minutes, and then my colleague Heath will offer some information about what you're seeing here, this curriculum, and how you can get it for your students. And then we'll say so long for now, hopefully not forever. So these responses here, I just loved all these here. I have, what I've done here, look at that, isn't that pretty? I have clicked on them with this checkbox right here. And what that's done is it's put them over here in this side panel, which is our snapshots panel. And I can take these and I can save them for later if I want to. Save them into my snapshots tab so I can look at them on Friday nights, because that's what I do after on the weekend, is just look at interesting mathematical thoughts, or press present and just share with you just how excellent I think these are right here. So how far apart the dots are from that center line. And someone noticed that it didn't change on each tank, which I think is so tremendous. And I didn't realize that myself. Someone describes that these are how far apart the data points are from each other, which seems really accurate to me. When they're closer together, they seem to have a smaller standard deviation. And someone else just says, hey, this looks like a geometric, like a parallelogram version of the data. I'm here to say, absolutely correct and very helpful. And I want to help us think about how that parallelogram, what it's indicating and how it was formed. And finally, I thought this was just a really readable, at a 4th grade level even, summary of what standard deviation means. Big fan of this right here. The lower the standard deviation, the more similar the fish. Higher means the fish are less alike. Huge fan of that right there. What I'll invite you to do here is to continue to explore all of we have 179 people in this activity, and all of us have a different idea about what standard deviation is. And as Dr. Rochelle Gutierrez says about thinking, none of these ideas are misconceptions. They are only conceptions. They reflect what you earnestly understand right now in this moment. And to help you develop those, you need to see more stuff. You need to see stuff that challenges those conceptions, that helps the person who thinks that, well, it's just a parallelogram, think more about how it's being created. To help those of you who think, it's just about the mean, to see different kinds of, fish tanks. So here, there's 3 different explorations we'll have you do here. Here, we're going to invite you to make a fish tank that has a large standard deviation. Here, we'll have you create a small standard deviation, but for a bunch of you, this might challenge you a bit. Make sure it's greater than 0. And finally, on this last one here, I tried this one, and I gotta say, as a math teacher, I was a little bit surprised by this one. I even have my conceptions about standard deviation need a little bit of tuning up as well, even. But add fish, 1 fish, 2 fish, as many fish as you need to here, to increase the standard deviation. And think about what you found surprising there. I've been pacing you to 1 screen at a time, which is nice when we need to learn together. This is going to be a moment where I'll pace you to those 3 screens and let you work a bit on your own pace. But I'm going to ask you to take just no more than 3 minutes, on these 3 screens, 1 minute per. I'm going to unpause you folks and then bring you back shortly after that. Over to y'all. Wow, I just looked at screen one and saw something I thought was really interesting. I captured it, want to share with you in a second. Keep on going here, folks. If you feel done, I would love for you to share in the chat something you thought was surprising. And you might answer this even from the perspective of a math teacher. Like, these concepts are surprisingly rich to me and not well understood even by a lot of adults. I thought this was pretty interesting myself. If you're done, feel free to share something surprising to you in the chat. I'll wrap this up with you folks shortly. Yeah, Marco's comment, which I think only is visible to the host and panelists, not to everyone, but I'll echo it out. Yeah, Marco and I share the same surprise. Yeah, there is a reset. Yeah, let's see. 2 fish on either extreme has a lower standard deviation than 1 fish on either. Yeah, this is, so for one, there's, yeah, there's that last screen. I'm glad that I'm not alone in finding some of this surprising and complex. I'm going to pause you folks. Go ahead and join me back here. I want to share a couple just observations here that I snapshotted these right here. I thought that this was cool and very helpful for me. Some people did not yet successfully increase standard deviation, which speaks to the challenge here. I'm so with you here. So yeah, right here, I love this, that you can get a standard deviation of 4.5 grams if you have 2 fish on both extremes, or if you have 5 fish on each extreme. That's super interesting to me. That however we're defining spread of data, these wind up having the same definition of spread. I just want to say that when it came to this screen where we ask you folks to make a fish tank with a small standard deviation, that 0.3 grams was the smallest that I saw. I didn't see anything smaller than 0.3. I love seeing how you folks chose the 4 and the 5. They're like close together. Yeah. Some people struggle with the wording on Explore 3 here, thinking that they like needed to add like fish is both a singular and a plural verb, which got us into some trouble here, where you thought you could only add one fish. But that's not the case in adding 1 fish. It seems like there's no way to add 1 fish and to increase the spread. Like right here, if I add a 10-gram fish, it pulls the center closer towards what I just added, which has the effect, because of where the fish are placed, of decreasing the spread. That is super wild to me. And the same is true for 1 gram right here, super wild. It turns out that people were adding fish on both sides like this. And that keeps the spread, it looks like kind of towards the middle again, but puts more distance away from that center. And that's what standard deviation is, as best as I can understand here at this level, is that if you find the middle, which is the mean, which we've done, and then we figure out how far away the different points are from that, take the average of those centered points. That's not math that students need to understand here. I'll let you know what happens in the rest of this activity is we then start getting into the numerical values here and ask, like, which of these do you think has the largest standard deviation? And I love that there's so many surprises packed throughout this activity. If you ask students to define mathematics in 1 adjective, how many of them would say surprising as that adjective? Predictable, more likely, right? But here, this idea that even though these fish are larger, that they will have a smaller standard deviation than these fish right here, which have a smaller mean, a smaller central, measure of central tendency, a smaller middle number. They have a greater standard deviation. That's a trip. We also invite students to use the calculator here, which I love, given the grade level standard here, we let students, calculate standard deviation of the population here using this right here. And knowing that they can do that then allows us to ask so many more interesting questions. Like, okay, so you did this based on your gut instinct alone. Now do it using the calculator and see if you were correct, which is more correct. And then this screen is just a bonanza. Right here, like I would probably save this for the end and maybe even like put it up on the wall, print it out and put it on the wall as a kind of bounty and ask students like, okay, get real confident. I was looking at some student dashboards of classes out there in the world who've done this one, and there's a lot of disagreement about which one of these will make the standard deviation larger. I love this. Increase each value by 1. Just seems like it's got to make the standard deviation larger, but I don't think it does. I think it makes that mean number larger, but that doesn't matter when we're looking at the distance of each point to that central mean number. I think it keeps it the same. So interesting. Add a 0, remove the 7, super wild. So anyway, this keeps on moving. There's a synthesis here. I think you folks could answer this really well. We won't at the moment for reasons of time, but the idea that you now can think about ideas like mean and standard deviation and connect those to a water tank. Like I show you these 2 tanks with numbers only. And because of the thinking you've done, you can picture in your mind's eye, many of you, most of you, all of you to some degree, you can picture all the fish. That is cool. That is mathematics. Then there's a cool down, which gives you some really definite feedback about what students have taken away or not. And that's a lesson right there. That is a lesson in the Desmos middle school math curriculum. And I just want to put out there, the way this oftentimes goes for students is like, okay, today we're going to learn about something called standard deviation. You're going to watch me calculate standard deviation using 3 examples. And then you will have 20 examples and you're going to calculate those and find the answers out later. And there's just no room for all the kinds of interesting early ideas that we saw from you folks in the snapshots here or earlier. Those ideas like, well, it's the kind of how spread out the fish are or how similar they are to each other. Just some brilliant stuff that we as a class will talk about for days and weeks to come. Or we'll refer back to those kinds of ideas. We will. So I love these lessons. I love this curriculum. You folks have lots of questions about this and that. Megan, can you come off mute maybe and let me know if there's some questions that would be helpful for me to answer, or we could kick this over to Heath.
Yeah.
Real quick.
Could you, I think the easiest one to start with is, could you show how you could translate to a different language for the students?
Yes, of course. So let's see here. When students log into this, I may not be able to. Let me see if I can grab this right here. I'm going to copy this link address and head into incognito mode, or as I call it, cool mode, and continue without signing in. Dan. Okay, so yeah, now I see it here. There is, I'm going to go ahead and unpause this and unpaste this, by the way, so you can move throughout the cabin. And then, how have I not done this before? There is a globe icon, not here, but right here, that lets me translate to Spanish. And that will change the web interface right there. And there is also on the activity page, you'll see this ESP right here, and it indicates you can run this activity in Spanish. So students will change this globe icon right there, and that will translate into Spanish. Great question.
And then I think the last one, while you're in the platform right now, could you show, there were a couple questions about finding out who the student is when it's anonymized. Someone said in the chat that if you have 2 screens, you can see the anonymous one, but that doesn't happen for me. How can I see the real names on my private screen and anonymous on the presentation screen?
Oh, to switch them up. Yeah, I think we mirror this decision on both screens. So changes you make in this browser, and I had a separate window open so I could check out responses too. It'll be mirrored. One thing you can do is hover over student names. So if I hover over the anonymized name, it'll tell me who is doing what. And if there's a student that's, typing things that are not mathematically productive or helpful, you can click on this and click hide student, and that will mean the responses won't show up on the dashboard or in that 3 student what other students said. view. You can always also go down here after you've had a conversation with that student about what they were saying or contributing or not contributing. You can click on these three dots again and then unhide the student and you're back, and let's hang out and have some fun. Great questions.
And then the question about how do I get this lesson in my classroom tomorrow? I'm actually going to turn it over to Heath because he'll show you this and then the other lessons, which are about 2 free lessons per unit, or you could sign up for the 30-day trial.
Right on. Thanks, Megan. Thanks, Heath. Over to you, folks.
Thank you so much, Dan. My little beta back here was riveted during that entire fish tank lesson. One thing to note about that lesson, it is available for free. It's one of the lessons that's available for free to all teachers. You could try it in your class tomorrow or next week if you'd like some time to practice, and I will show you how to do that in just a minute. First, let's talk just a little bit more about what makes Desmos Classroom lessons so great and how you can bring Finding Desmos to your classroom. I'm going to go ahead and now share my screen. All right. So what are Desmos Classroom lessons? Well, they're a lot of things. It's a core math program that blends the best of paper and technology. Desmos Classroom lessons offer learning experiences on computers that are dynamic and interactive, as well as experiences on paper that are flexible and creative. The Desmos Classroom grade 6, 8, and Algebra 1 lessons are adapted from illustrative mathematics, IM K-12 math, and aligned to standards. We've applied our expertise in technology, pedagogy, and design to enhance the experience for both teachers and students. At the foundation of Desmos Classroom lessons is the idea that we need to put students' ideas at the center. Our lessons pose problems that invite a variety of approaches, and our technology helps teachers celebrate and develop all of that interesting thinking in their own classrooms. And we have powerful facilitation tools, which you all just got to experience firsthand, that help our teachers. Our problem-based lessons empower students to explore new ideas, and our teacher dashboard helps teachers connect those ideas together. Whether teachers are observing student learning on our lesson summary page or guiding productive discussions with our conversation toolkit, our facilitation tools make teaching more effective and more fun. And with a full Desmos Classroom lesson subscription, you'll never have to do any of this alone. We offer tons of robust professional learning and support services. For teachers, we have orientation webinars, tutorials and support, webinars on unit overviews, emails for lesson previews, email support from the help desk, and a vibrant Facebook community where you can learn from teachers just like you. I'm sure some of you are already in that Facebook community. It's very, very busy all the time. I love it. Differentiation support is also so important to us. Our activities are fully editable with suggestions for English language learners and students with disabilities, math language routines, and are you ready for more challenges? And finally, with a subscription, you'll have your very own dedicated Desmos coach, your thought partner on all things Desmos Classroom lessons for the year. And I see some familiar faces of friends and colleagues there on the screen. Before we get to our final Q&As, I did want to point you in the direction of where you can sign up for a free 30-day trial with access to all Desmos Classroom lessons. Visit amplify.com/Desmos Classroom to create an account and sign up today. And we did have a question come in about finding this particular activity and editing it. So I did want to just walk through that quickly. I am already signed in here. I have already signed up. I'm going to search for Finding Desmo. You can search for the lesson directly. And then if you want to teach this lesson as is, you can assign it to your class from here. If you want to take the lesson and modify it a bit for your class, you can click these little dots here and then click copy and edit. That will make a copy of the lesson in your account that you can then edit as you see fit. So yeah, just wanted to show you exactly how to find this particular lesson. And then as Megan said, you'll have access after your 30-day trial to 2 free lessons per unit. Those will never go away. And then for your 30 days, you have access to the entire curriculum. Let's pause here for final questions that may have come in. And Dan, I may rely on you and Megan as well for some help answering these as they come in.
Dan, do you have advice about working at answering questions or working with the questions and the answers at the pace of the class. So this individual said they find that it goes so fast that they're not pulling out the responses they want. And usually the students are getting done before the teacher has the opportunity to pull those questions maybe into the snapshot or highlight them.
Yeah, it's a great question. And we are just we're inviting you folks to learn to teach in a different mode with a different tool. I often think about the kind of the giant robot mech suit that they wear in some sci-fi movies. That's what this is. Like, we are inviting you, we're trying to offer you tools that make you faster, more efficient, more powerful, but really amplify your existing capabilities. It's tricky. And so one thing I would say is that each of those screens that I offered you back there, they have, you can go deeper into them, and that's only possible when we use that pacing tool. Without that, students tend to just like tear through an activity, skipping along the surface of the water. So what you saw me do was keep us together to invite you perhaps to try another fish tank, try another one, which gives me time to just pick 4 responses or 2 responses that might help us develop our collective thinking a little more. Short version, this is tough. Long version is we've got tools to help you.
I can take the one about availability. So right now we are developing a pre-K through Algebra 2 course. So starting next year, we will have kindergarten through Algebra 1 available on a rolling release, and we're working on the high school schedule right now. We answered these ones. How do you keep students from just hitting return to see their classmates' answers to copy? Yeah, that's a good one.
I love this question.
Yeah, so fun. So here's one thought about it that might be controversial, is that what you're describing, first of all, is another name for learning. Not necessarily the learning we'd love, but definitely like students interested in understanding an answer. And like by seeing another person's answer, they are not learning nothing. They're reading that and perhaps even thinking about it. You wouldn't want to copy and paste an incorrect answer, for instance, and you have 3 to choose from. That's one thing I think about copying from those 3 student responses. Here's another though, is that over time, students want to be selected. When you hear me say about your classmates, this is so interesting. And you hear me say that about classmates that are not just ones that have the A's and A minuses, the top grades in the class, but even students who are struggling with the formal mathematics. When I say, ooh, a visual parallelogram, I love how they're tuning in there. That says to students who might be otherwise inclined to copy, like, oh, like I too can be successful here. And it sets up the incentives in a different way. So students feel less inclined to just copy. When the floor is low enough and the incentives for participating high enough, there's just not a lot of reason to just copy so broadly. Great question.
Yeah, there's a couple questions I think that would be best answered from someone from the technology portion or maybe from the coaching team. So some of those, just for those in the chat, that may be about migrating or changing your email address. Go ahead and go to amplify.com/Desmos Classroom, and you can click on get in touch, or there's the email addresses, and someone will get back to you about your specific case. But we're glad to help. Very, very eager to help. And I think we answered all of them. I don't know, Dan or Heath, if you have anything else you want to add.
I don't think so. Just thanks to everyone for taking time out of what I'm sure were extremely busy days to join us tonight to learn more about Desmos Classroom lessons. I hope you're all leaving here wanting to try Desmos Classroom lessons in your school so you can help celebrate your students' brilliance every day. Again, visit amplify.com/Desmos Classroom to sign up for your free 30-day trial to get started. And thanks again to Dan for the amazing Finding Desmo lesson. I know I learned a lot. It's been a long time since I had to do any algebra, so thank you for that. And thank you all for joining us once again. I hope you all have a great night.
All right, folks, thanks.